Mr. Chandrakant Patil, currently serving as a project in charge at MAPRO Foods Private Limited, Panchgani. I am having a civil engineering experience about 40 years, being as a project management as well as a construction. I have done many projects, industrial, commercial, residential, with Kumar Properties, Mopatlal Spinning Mill in Mumbai, Bridge Candy Hospital, Raymond Showroom in Mumbai, and now working with the MAPRO Foods. I am very much thankful to the Mr. P Lele, President of Ferrocement Society, given an opportunity to give some details about my project, about the ferrocement. For ferrocement, actually we are very new in this field. We searched for doing one project at Wai. We are doing one big project in India as a snow park. It is about nearly 30,000 square feet area. This is owned by Mr. Mayur Vora, who is the owner of the MAPRO Foods Private Limited. His vision was, we are doing snow parks, so why we can't build a Kailash in that? Because snow concern with the Himalaya, and Himalaya is our, I think, world's center point. So his vision was to build a Kailash. But how we will build the Kailash? That was a question. Then we searched many sites online, how we'll build. Then we came to know about the ferrocement. For the ferrocement, we are actually new in this field. So we found one name, Mr. P Lele. Then we decided to call them and have a meeting with them, and will let us know how the ferrocement works. So during this construction phase, Mr. Vora prompted a discussion about the project name. After deliberation, he proposed the name as a Kailash, drawing inspiration from the universal presence of the snow. Our architect, Mr. Shrikant Uttale, he is from Satara. He has taken much effort to make these all structures. He made many options for this. Then we finalized some projects designed from him. Then after doing all these efforts from the Mr. Uttale, he made from the online contours for this Kailash. You can see in this. Yes, this is a picture of Kailash, originally standing in Himalaya. For this we found some contours on the line, online. Then we implemented this on ground. And then this work we gave to Mr. P Lele to start with this. He made a very good design for this. He will explain all the design part and the execution part for this. I will hand over to Mr. Lele. He will explain everything about the ferrocement because we are very new in the ferrocement, and he will give the details for this. Mr. Lele.
Thank you very much, sir. And I am thankful to MAPRO Foods also for giving me opportunity to build this old Kailash. Actually, I can say it is a Himalayan task for the design also, because architects have taken much efforts to draw the contour map of the Kailash. From the pictures and from some downloading, to scale it up to the required scale, because our actual Mount Kailash is much higher, but we are building in 14 meter height and 50 or 60 meter length. So he made the drawing matching to these dimensions. That is also a Himalayan task, because those who know how the drafting is done and how drawings are drawn, they can understand what is required to draw such things on the paper with skill. Now you can see it here. This is the contour map. This is the contour plan. You can see how these contours are closed and there is spacing between the contours, and there are three mountains, you can say. This is central part of the Kailash. This is the actual Kailash. This is top height is 14 meters from the base level, And these two mountains they have kept because normally their range of peaks in Himalayas you can see their range of peaks. So this is main peak, that is Mount Kailash, and these are other peaks, and their purpose is somewhat different for that tourist attraction. Because on one part of it there will be some climbing and these things will be there. They are planning like that, and we are making some changes accordingly because some adventure sport like thing will be there. Now, actually, while planning, the design was made from the photos, scale calculated that I have explained. There was a circumambulation, we call it pradakshina. Normally, when everyone visits Kailash, they take a pradakshina to the Kailash. So that provision is also made there, because if someone goes there with some religious thing, so he can take around.
Actually, Pradakshina is of 52 kilometers around the Kailash.
Yeah, he has studied Kailash very well.
Yeah.
He can't tell anything about the Kailash now.
Yeah. It is a 52 kilometers around the Kailash we can walk. It will take near about 10 days to complete one Pradakshina.
So it will be
Concept also we have made in this.
In this-
We have one staircase to going up and
here you can see
Parikrama
from
around
here
Kailash.
we climb the stair,
Yes.
go in the there is a ramp here and come down from this way.
Yeah, it will
That-
be one Pradakshina.
That will be one Pradakshina.
How much distance?
Here it is near about 52 meters.
Okay.
And there actually it is 52 kilometers.
Okay.
This will be 50, say this will be maybe 100 and 150 kilometers, taking all around. So various services are also required in such thing, because air conditioning is one of the most important services, because that temperature will be there around -5 or -6 degrees. So this they have built a shed first and it is insulated all around. And in one part of the shed they have made cold storage. Roof is also insulated, and one
Cold
part
storage is of -20 degree temperature.
they store their strawberries there and they are using that. Inside there will be meditation rooms also. Adventure sport, just now I explained to you.
Below the Kailash there is a much space open inside. So we are using it for a meditation or any other purpose.
Meditation rooms will be there below the Kailash. AC and also cleaning of ice or snow is also required. So some drains are provided in the flooring.
We are buying brooming machine that will be brooming in the night. The ice which will be the dirty in the daytime, that will be broomed in the night. So next day it will be fresh.
And they are also brought a snow making machine. That
We
will
are
be
having
there.
the 3 snow making machines. So we will make a machine at a spot. Even on Kailash we are going to have a near about 300 mm thickness of ice. So that load is also considered in the design.
Now ferrocement design and planning comes in picture. There were some requirements and constraints for the design. Shape, as you have seen, shape is important. Just erecting any mountain is not desirable. That shape has to be there exactly as per the photograph. It should look like that same photograph. That was the most important requirement. Structurally, it has to be safe because people will be going around. So it has to be safe. Space below has to be utilized. Otherwise, it would have been very easy. Just make a mountain of masonry or stone and bring the shape. But it is not the case. That space below should be utilizable. And one more constraint is there because they had done the flooring. And below flooring, they have run some pipes.
Yeah, we are having PEX pipes inside the floor to run a glycol which keeps the floor cool. That is the main actually, we can't disturb that pipes. The PEX pipes of 12 mm diameter, we will running the glycol liquid through the pipes because glycol liquid keeps floor cool.
Ethylene glycol?
Ethylene glycol, right.
So,
Because of that only we can't drill anything in the floor. Above that we have made one raft of 200 mm thickness, both side reinforcement. And on that reinforcement we have built the structure without any puncturing. We did
How much
only
is the temperature
rebarring.
outside?
Pardon?
Temperature outside the tube, glycol tubes or in the floor?
It will be minus 20 degree.
Minus 20.
Yes,
Glycol freezes at
minus 13. Minus 13.
So we had a limitation. We cannot drill the hole deep inside. Maximum 50 or 60 mm. He said that you cannot drill the hole more than that. So that constraint was also there. So our structure has to be self-standing. That was a requirement. And without taking any support from the structure, because they have erected the structure, but we cannot take the support of that structure for the shade. So it has to be self-standing. That was another requirement. Then how it was designed? Firstly, we marked all the contours on the floor with full scale, required scale, because that 14 meter hand and length 50 meter or something like that. So all the contours were marked on the floors. Grid, we marked a grid of 300 mm by 300 mm. So when all the contours were marked, I found that between the 300 mm, contour lines are straight. So it is clear that if we erect and made the straight lines between 300 mm, we will get the exact form of the contours. So we decided to go that way. Initially, supporting structure is required. We cannot just make a ferrocement slab or wall of that 30-40 mm thickness and give the shape. It is not possible. So supporting structure has to be there because the span, widthwise span was also I think about 15 meter or so. So naturally two walls were spacing 15 meters apart. So that 15 meter span is much more. We can, and again that shape of the wall is also not straight or inclined. Plane surface is not there.
Undulation like
all the undulations were there. So initially we decided that we will keep the framing at support at 1350 mm spacing because that is optimum span for the ferrocement. If the span is more, then we have to increase the thickness. And for 30 to 40 mm thickness, 1350 mm is okay. That is fine. There will not be cracking or bending, anything like that. But later on we changed to 1200 mm because that support, vertical supports were there. And in between the space, in between the two supports, 1200 mm was equally dividable. So that's why we made it 1200 mm. We also thought of keeping main support at 2400 mm to avoid vertical supports in between. But later on, we come to know that if we keep it 2400, we will need support at 1200 mm. Then cross beams will be there. So there will not be any saving. Again, for design purpose, we have to draw the section in both the directions to work it on. So that idea was kept apart and we made the frames at 1200 mm center to center. Now section, as already explained, section we get the section from that contour plan at 1200 mm and every section was drawn on the drawing. For every section drawing was made. Vertical support were provided at the ends only because space below should be utilizable. So there are far minimum vertical support in between. Practically there is no vertical support in between. All the supports are at the end only. What happens if an inclined surface is there and irregular surface, we have to tie opposite ends. So we provided tie beams at connecting opposite ends at certain intervals. At bottom also we provided a small tie beam because that's how it will pair. It will go, two ends will go apart. So tie beam is necessary and anchorage in the flooring was not possible. That's why we provided small tie beam with some minimum inserts in the floor that make the depth of tie beam minimum.
Do you have pictures? Pictures that can
Yeah. Pictures are there. I am explaining design detail. There's some many photographs are there. N number of photographs are there. And actually, it is better. I advise you to visit the site. And site, I can explain you better. And there is always limitation. The span is too much. To show all the pictures of every part becomes difficult. That timing, depth of stabbing was much more due to the span. Minimum span to depth ratio we have to maintain. So while concreting, we know that below neutral axis, concrete is redundant. In the company, they were having many pieces of insulating material because they have provided insulation at many places. So we use those insulating pieces in the concreting, above that bottom layer and below the neutral axis to reduce the weight. Also some cost is reduced in the concreting. That we did there. Instead of making beam hollow, use those insulating pieces, thermocol, lightweight. The insulating material pieces are there. Some steps are also planned in later stage, exact how much steps are required, we calculate accordingly, and some provisions are being made. On the paper they are made, practically they are being executed. You can see on the site visit. So execution stages I have already explained. First, marking of plan, making frames on the floor and fabrication, erection of frames. Now I'll show the photographs, and this is the actually picture of the frames. Initial stage. Because after making the design, architect made this picture.
There are total 38 ribs.
38 frames, we can say.
38, starting from that end to this end.
Total 38 frames are there. And you can see the top of frames.
You can use the mic. You can use the mic.
Top of frames, if you join the top of frame, that will give the shape of that mountain. That's how we made the frames, planned accordingly.
टॉप टू टॉप जोडत गेलं तर तुम्हाला तो
Yeah, that's you will get the shape. These are the initial frames. These were erected. You can see the person standing on the frame. And these frames were erected with the help of crane. And totally here, those pictures are difficult to see because there is, you can see two beams running, joining the columns.
There are tie beams between old structure which is built in the PEB structure. So because of that beams, there is a disturbance to erect these type of ribs.
These frames, we cannot make a frame just erect wholly. We made the frames, cut them
In two parts.
erected one part first, another part then, and again joined in the place.
रिवेल्डेड
Revealed.
Yeah.
And for that, we use some angle pleats with bolting. Before cutting the frame, we provided angle pleats and bolt in between, cut between those two, and then with the bolt, exact position were achieved.
Then that joined.
Exactly the same profile we got. You can see here how, and we started with the highest
First,
first.
which is a 14-meter height.
14
That
meter
rib we have started first.
We started first because water problem will come. That will be sorted out in the first 2-3 frames only. Then there will not be any problem. Start from the difficult, then everything will be simple and easy. So we started from the difficult portion.
For this, actually, we got an advantage of the contour plan. Without that contour plan, we cannot done this.
Here you can see the shape, exact shape that you have seen earlier. I show that photo again now.
This shape is almost we have achieved. You can have a look tomorrow.
This is the shape initially we had in mind, and after erection.
Pardon?
This is only on this axis. How about this axis?
No, that is actually
Backside.
Backside, actually, that you have seen in the photo, there is a ramp.
Okay.
No, actually, for the snow park on the opposite side, we have made up one slope rides for the
Here you can
visitors.
see. Here you can
And
see.
just, there are some sloping rides behind.
अच्छा, skating.
This is the north elevation, which is looking as in the original Kailash. That only we have faced from this side. The back side is not, we have done much.
Because everything is required in one place. Snow park and adventures and everything, and also with Kailash. That's why only that portion is used.
Only elevation purpose is finished.
Yeah, elevation
per
and
point.
some side elevation also,
Side
some partially.
Sir, back. एक मिनिट back लागेल अजून back.
Here you can see that there is a ramp.
Ramp.
Back side.
And here, these steps are going up. Actually, then later on we match these steps with the ramp. People will climb up from this step over the ramp. From here, they will come down. This portion redesigned later on, and they are coming down from these steps. And some adventure sporting will be there.
Yeah.
They will be climbing from this way, going to this.
There will be a Burma bridge in between that highest rib and that sloping slab. There will be a Burma bridge.
In between. That is for some adventure sport. That portion is now later on redesigned, and we are working on it now.
Yeah.
Have you thought for the physically challenged people also?
No, physically challenged people cannot climb this, cannot go in the.
But ramp and all these things.
Yeah, that we have taken care of. We are putting escalator for them to go up.
Grandchildren are playing, grandfather wants to just go around do pradakshina.
That may be possible, depends.
The bottom is a column.
Yes.
Yeah. This is vertical part.
Vertical part.
This is vertical part. It is like a column.
Okay.
Acting as a
We
column.
are about 400 mm width.
Best.
Okay.
Very nice.
Good.
Now this is mortaring, you can see it here. Mortaring work is going on. And you can judge the scale because you can see a person standing here. And this is 20 feet ladder, and you can judge the scale of the.
Yes, yes.
Press filling from both sides or single?
Both sides.
No, press filling actually, everyone was telling that there is no need of shattering for the ferrocement. But personally, in my opinion, when we learn that we insist on your specific surface, that bond between the meshes and mortar has to be perfect because we count on it. If we press it from one side only, even though mortar comes out from other side, that it is thought that there is no need of pressing it more. But I tried here, I fixed 3 mm ply on the bottom. I tied it to the meshes because shape is confirmed that shape is not disturbing. So after tying that plywood from below, I initially finished that surface with press filling that we normally do. Then I use needle vibrator with 25 mm needle. And then I observed that mortar goes down. That means that there is some voids in between. That's why it is going down. And cement water is coming out later on also. So that is the area for the study also. Many academicians can study over it, why it goes down, and properties with press filling by hand and with using vibrator. What is the difference that you can search this, make a research over it, and I will be happy if I get the feedback. Basically, if we use plywood from below, that cost is not much. Increasing the cost is not much. On other hand, we can save finishing labor from other side. That may be making the cost same. So practicing people can think over it and use this practice. By the way, it is not included IS code.
What is not included?
This use of shuttering or anything. We are not including IS code. IS code is keeping silent over it. So this is another mountain. You can see in another picture that mountain, second mountain. It is not Kailash, but in Kailash range. That is, I think, imaginary or something like that.
Yes.
It is imaginary because to make that in Himalayas you will find there is always a link of
Mountain
peaks.
range.
Mountain range is there, small bigger peaks like that. This is another view that work is going ahead. Actually it was difficult to take photograph there because it is in the enclosed shed. So light is very low. So I brought the photographer and he came with some floodlights and everything.
Actual picture we can see tomorrow.
Yeah. Tomorrow you can see actual picture of it.
MAPRO is inviting all to come.
So we'll take a review of tomorrow's tour also.
Yeah.
Number is to be decided.
So thank you very much.
Thank you.
Listening me patiently.
It's a great and challenging job.